This is a Marconi B29 low frequency receiver, and the dial cord is broken, and at the moment I can't get the front panel off because 3 of the knobs have got locking pins through the shafts and the knobs that have seized up, and rather than destroy the knobs I decided to try putting a digital frequency meter on the set instead. Now this is a tuned radio frequency set, so it hasn't got an intermediate frequency, but what it has got is a beat frequency oscillator that works about a kilohertz away from the actual tuned frequency of the set. The set covers 15 kilohertz through to about 560 kilohertz. At the moment it's on the lowest range, which tunes to 15 kilohertz, and I've got the tuning gang is now at the maximum mesh, so that should be around about 15 kilohertz, and the frequency readout is 15.6, so that's pretty close. Just as a double check, I've got the scope here, which is at the top right hand corner of the scope screen. There you can see the frequency counter is 15.62 kilohertz there as well, and a pretty nice sine wave. And I'm taking the signal from the beat frequency oscillator directly from the tuning capacitor for the beat frequency oscillator through a 10 picofarad capacitor connected to the stator, through a piece of miniature coax, and then through a 1 megohm resistor to the digital frequency meter. So it's pretty straightforward. It's just low amount of coupling. There's actually quite a lot of radio frequency signal at that point in the circuit. If you look at the scope again, you can see it's measuring 24 volts peak to peak. And this digital frequency meter will take up to a couple hundred volts, so we're good. And actually the scope is reading directly from the end of the 10 picofarad capacitor, whereas the DFM is through the 1 megohm resistor. Just add a little bit more decoupling. So that's at the lowest frequency on the lowest range. I'll now turn the frequency up to approximately halfway along the dial, which is around about there. So that should be something in the order of 24 kilohertz. And that's what we get, 24 kilohertz. I'll just wind it fully to the top end of the dial. That's reading 38 kilohertz. It should be reading about 38 kilohertz on the pointer if it was operational. But the DFM, which has got a faulty digit, by the way, is 37.8, so that's pretty close. And that's what the scope's reading as well. And I'll switch it to the next band up. And the top end of the next band should be around about 90 kilohertz. And we're reading 85.6. So needs a little bit of alignment there. Stick it to about halfway down the band. And that should be reading something around about 55, 56, something like that. And we're pretty close, 56.8. Take it to the bottom end of that band with the tuning gang fully meshed, and we should be reading around about 36, and we're reading 36 kilohertz, 36.4. That's pretty good. Next band up, bottom frequency here should be around about 90 or just under 90. We're reading 87.5, which is pretty close. Just wind it to about halfway mesh on the tuning gang, about there. We should be something like about 140 kilohertz, and we're reading 138. It's pretty good. Take it to the top end of the band, so the tuning gang fully unmeshed. And we should be around about 220 kilohertz, and we're reading 214.7. So again, a little bit out there, needs some alignment. And the highest band top end of the highest band should be around about 560 kilohertz, and we're reading 530. Take it down to about halfway, half mesh, we should be somewhere in the 360, and we're reading 349. So again, not too bad. Take it to the fully meshed, the lowest end of this band, and we should be around about 240 kilohertz, and we're actually at 225 kilohertz. So again, it's a bit out there, some alignment necessary. I haven't got an antenna on this at the moment. I've just got a signal generator, which is generating 16.3 kilohertz. So I'll turn the volume up, and we're at the lowest end of the lowest band. And zero beat is at 16.4, 16.2 kilohertz, and we're reading 16.3 on the signal generator. So that's pretty good. I think you could use this receiver with a digital frequency meter connected to it. So there's some options open to the owner. One of them is I can fit a socket somewhere discreetly on the front panel, so you can plug an external digital frequency meter into it to use the receiver, and you can get a machinist to try and remove these knobs. It says a hard steel pin needs to be drifted out. I was concerned I was going to break the knobs, and I couldn't find any knobs like this in my supply or in anybody else's supply. I'm sure they do exist, but I haven't got any. And also the third one that needs fixing is this antenna input lever, which is metal, and that's got the same issue with a drift. It needs to be drifted out, a metal pin there. So if you can do that, the front panel will then come off and you can restring the dial. If that isn't possible, two alternatives: you either just use the receiver with an external frequency counter, or you could move the scale back and put a modern digital frequency display actually behind the dial here, so it would be a digital display on the receiver. Not exactly authentic, but it would be usable, and the owner does intend to use this receiver on low frequencies, so at least it would be perfectly usable. And of course the beat frequency oscillator fine-tuning here, which is called heterodyne vernier on this receiver, works as well. But it actually tunes this as well, because we're actually monitoring the beat frequency, not the actual receive frequency. So we're a little bit off, because the beat frequency is about a kilohertz or more away from the actual receive frequency. But I think we're within a few hundred hertz there. That's pretty good. There we go, digital frequency meter readout on a B29 receiver.